Okay, thank you, Rutger. I did indeed first use an example how to order a pizza, but I thought now it's time to be a bit more serious and to talk about a real-life example. And also the language I was working on was called OLE, not the Microsoft OLE, but it's called Object Logic in English. But since then, we've been working on an either higher level language, which I would like to show you today. First of all, my background, I have a background in mathematics, computer science, and databases. I consider myself an expert in process and data modeling. I founded my own company, it's called Integrand. I also work in academia as a part-time associate professor, and I'm a partner at Contracts 11. And Contracts 11 develops contract-based software systems. What I would like to talk to you about today is, the title was Processes plus Contracts equal Blockchains. And this is not, I'm not going to speak from a technology perspective, but I'm going to speak from a business perspective. I want to talk to you about what this has to do with business modeling. Why is an end user possibly attracted to a blockchain solution? What we see now is a lot of technology push. We see solutions in search of a problem. Let's look at it from the other perspective. And first I'd like to show you what are typical problems that you come across in business and why a blockchain, even in a very simple setting, can be a very good solution. And I think the right way to do it, because these applications are often very complex, is to use models. Models are abstractions from reality. They let us focus on what is important and what is not important. And I think that processes are very important, so let's first try to model our business processes. So people want to do something, they have mutual goals, they have critical success factors. So let's try to find out what we want to do. So we build a business process, and then we try to find out what is important when we're looking at the data part of the process, and how do we find out which data is relevant for the process or not. And actually, contracts, smart contracts, are a very good way to find out which data is actually relevant for the process. And then, when you look at the result, the business process and the smart contracts, then you see that a blockchain just starts to evolve very naturally. So it's not, I also don't think it's very disruptive, as I don't even think it's very disruptive from an organizational point of view. It's just, well, you have to get people to get used to the idea that a blockchain could be a very natural solution to their business problem. First of all, an example. 2015, maybe you've seen this in the media. The municipality of Amsterdam, they found out that there was a loss of 24.5, to be exact, million euros that was transferred to unknown parties. This was a loss that was never resolved and probably will never be resolved. Also, they found out that wrongly calculated large amounts of money were paid out to the wrong parties. And also organizations like the above were unable to reconstruct what had gone wrong, let alone correct what had gone wrong. So these are serious problems. And when you try to boil down what is essential about these problems, you see, well, there's no transparency. Apparently the designers of the Amsterdam system, they had no idea about the terms and conditions that had to be supported. There was certainly no traceability. The errors made could not be recovered, let alone be corrected. There was no safety. There was no sufficient checking of rules. There was no sufficient delegation of responsibilities. This example can teach us a lot. When we generalize from this example, we see that if you want to trust your organization's information system, then there should be these three important aspects being covered. That is transparency, safety, and traceability. Transparency means there's a clear understanding of the terms and the conditions among all stakeholders involved. Safety, there have to be contracts that safely guard the rights and obligations of all of the stakeholders. And then traceability, there has to be some kind of mechanism, call it an immutable ledger, that logs all of the transaction events that take place in your business, and you have to be able to check whether these transactions were indeed carried out according to the specifics of the contract. And when you look into the literature on trust, the scientific literature on trust, what do you see? These are actually the three aspects that are important when you're talking about trust. So if you're going to talk about a blockchain as a database of trust, it's going to have to address the issues of transparency, safety, and traceability. Another thing is, if you look at what happens when people try to design information systems in companies, what you see is there's no integrated approach in modeling the process, modeling the data. Usually inside your organization there's a process guru, somebody who knows all about the business processes. And there are data gurus, they know all about your databases. There's one guru missing, and that's the one who knows how to glue the process to the data. Yeah? And actually, usually processes are designed individually, and data also. It's really strange. What you should do is realize that processes and data are flip sides of the same coin, and the coin is designing a successful business information system. Another thing is that people do not sufficiently understand that processes are more important than data in the sense that processes form the context of use. Yeah? Data in one business process can have a completely different relevance than in another process context. Yeah? Processes are dominant. To quote a famous philosopher, Ludwig Wittgenstein, he was the famous philosopher of language, he said, don't ask for the meaning. That's very strange for somebody who's doing philosophy of language, but ask for the use. In order to find out what you're going to do with your data, look at the use of the data. Don't concentrate on the meaning. And, well, what I coin here, business blockchain, is that if you look at Bitcoin, of course, it's fantastic from a technological point of view, and there are enormous prospects. But the thing is, normal people in business, non-technical domain experts, are often overwhelmed by what they are confronted with, the technology. They are also afraid that this technology can be very disruptive. Yeah? It could disturb their existing systems. Yeah? And in the previous talk, they said there was also something else that was very disruptive. It could also disrupt how people work with each other inside an organization. Blockchains have a much broader application scope than cryptocurrency applications alone. And if you abstract away all of the details, the implementation details, the architectural details, then you find out that there are certain common characteristics, and those characteristics could form the high-level conceptual model of what we're talking about. It's a starting point, yeah, for which we can actually see all of the blockchains, a very simple starting point. So business blockchains, they allow us to think about blockchain solutions in terms of a business perspective, an end-user perspective, a non-technical domain expert's perspective. So focus on the end-user perspective and do not focus on technology and implementation for a moment. That's what a conceptual modeler does. First of all, business blockchains, they start from business process models. From these models, we can figure out what the underlying contracts are of all of the activities that take place within the context of that business process. Once you have those contracts, then you can figure out which data is relevant for that contract. Which data do we need in order to execute the contract? Hence, we have process-driven data solutions. This is not really, this conceptual modeling is not something that I found out. I mean, it's something that's been around for a long time. Since 1975, you had the ANSI Spark 3-level architecture when you're trying to design databases. Databases were often designed for complex organizations. If you just try to build databases right away by using tables and foreign keys, you'll find out it's going to be a really big mess. So what you do is you try to build a conceptual model of a database to figure out what is important for the organization, what is not important. And then from that conceptual model, you can move on to a logical model and actually move on to a physical model, an implementation model. So we're trying to do the same here, the ANSI Spark approach to blockchains. The benefits of modeling is you're looking at solution spaces instead of just particular solutions. Yeah? They are giving you a sort of a bandwidth, yeah, within you can operate in order to come up with particular implementation solutions. One accepted business model can lead to very many software architectures and implementations. Another thing is these models, they can allow for end-user business validation before you start implementing. So get your models right, your processes right, your contracts right, your data right, before you start thinking about architectures and software implementations. So let me show you how this could work. Yeah? A certain business process as a context of use, and how do you model communicating business processes? Well, a recent example, last week, I think we all know this example, a new act issued by the European Union obliging banks to sell your customer payment data as a response to a request from a certified company unless the client explicitly refuses to let the bank know that they don't want their data to be given to that institution. All right? You recognize this one? Yeah? So that means you're going to Amsterdam with your wife and you're having a really good day and you don't have any cash on you, so you're paying with your credit card and whatever. And you had a really nice day, and you go to a restaurant, you go to a theater, you might even, because you're in a good mood, buy some lingerie for your wife. And then a week later, 2 weeks later, you're getting offers. Go to this restaurant, want some offers for lingerie, whatever. You say, hey, where's this coming from? Well, it could come from this. So this is really something that in the media was treated very negatively. I think that there are people who could explain that there are also positive aspects regarding this particular act. But the thing is, when there's conflict, for example, when you do get advertisements that you don't want, you think there's some kind of a breach of contract, you should be able to find out somehow that either the bank was wrong or the institute was wrong, yeah, because you had not given consent to actually use this data. So how could this look like? Because it's an extremely simple example, yeah, but it just show you how processes and contracts and data work. So let's offer the process model for this particular example. We're going to use BPMN. It's a good modeling language, nice tooling, and it's also the de facto international business process modeling language. Okay, this is what it could look like. Here we have what we call 3 pools. We have a pool on one hand of I have to look here because I don't have my glasses on. we have a third party, that's the institute, yeah, that is certified to request your bank payment data. The bank gets a request, that's the trigger, that's the green part here, that for the client payment data, and then the bank has to figure out whether the client has actually given consent, yeah, to offer this payment data to the certified third party. Because you could say right up front, I don't want anything to do with that, and the bank has to acknowledge that. In the case that you do say, well, sometimes it's okay and sometimes it's not okay, then the bank has to ask the client for permission. That means there's a request going to the client, and there's a response coming from the client, and then we have one of the 2 cases. Either the client gave permission or he didn't, and if he gave permission, then it's allowed to retrieve and compile the data and give it to the requesting third party. So this is typically how what a business process looks like. Yeah? We have the stakeholders spread over what we call pools and swim lanes. Each activity and each decision, that's a gateway, being made in a swim lane pertains to a particular stakeholder. And then you just run through a number of sequences, and you see that there are communication links between different pools. Now, the third party has to communicate with the bank has to communicate with the client, and this is all how it works. Where do the contracts fit in? Well, first of all, you see that the trigger is that a company is asking is requesting the data. Then there has to be a check. I didn't even put it in here. Is that company, that institute, actually certified to request the information? Then the bank has to find out whether the client has given consent, yeah, to offer his payment data. Then, in the case that he has offered consent, but case for case wants to say whether the certified party is indeed allowed to look at the data or not, well, there's a request and a response that's going on there. And then at the end, well, if all things go well, then, or not, if all things go well, that means the third party has been checked, you have been checked, you've been checked 2 times actually, and then you've given a consent, and then the bank is allowed to give the data to the requesting party. So that's how that worked. Now, I'm telling you what the checks that have to be made, but these have to be made very explicit because contracts are supposed to take care of, be safe, guarantee that the rights of all stakeholders are indeed upheld. So what we try to do is we try to come up with what we call a contract form, which is intelligible by somebody who is non-technical. Let's say a legal expert at a company, or somebody who's trying to develop an application, or somebody says, well, we have to do something, I don't know exactly what, I don't know much about technology, but I do know as an end user, or somebody who's designing something for my end users, I know what I want. Well, what we try to do is we try to come up with contract forms that support the notions of transparency, safety, and traceability. This is an example of such a contract. What we see here is that the contract forms, these are actually just paper, it's just text, for example, for somebody to read, and then they can either say, I agree with what's in the contract form or not, but these contract forms are actually a basis for implementation. So the situation says, well, what is the context of this particular contract? Well, in this case, there's a start event saying that a third party is requesting information about a certain client. Then there's a precondition. It says, well, the request has been made. You could also say that the third party has to be checked beforehand, whether he is indeed certified to do so. The contract needs an identification. Well, in this case, we need an instant, a moment in time. We need a third party, a bank, and a client. That's what we're talking about. The initiator is the third party, because they're doing a request. There's a responding party. In this case, it's the bank. And the requests are, check if the client has refused the EU Act altogether, then we're finished, and sign the contract. Then, very important is the context of the contract. In the previous talk, we were also, not the previous talk before that, it was about how do you guarantee that even if you have a peer-to-peer contract that works well, that one peer is also giving your information to another peer, and you don't know about that, well, that should be put into the contract as well. So important is that you also note in the context of the contract other transactions involved. Those means which other transactions are going to make use of my data. So there could be a whole chain of transactions leading to each other, possibly outside this context, and knowing, again, making sure that the person who is involved, that their data is not being shared by unwanted parties. So you have the situation, precondition, identification, the initiating party, responding party, the requests that are actually being made, the context, and then there's a postcondition, and the postcondition here says, check if client refuses the EU Act and check if it's signed, and if so, it will result in a control answer, and that's yes or no. And then there's a follow-up of the transaction, because that's what the contract, the smart contract, is supposed to do. There's supposed to be an execution. So one transaction event is going to lead to another transaction event. And if the control answer is equal to yes, then we follow with the transaction, ask client permission. Otherwise, we follow with the stop event, request denied. So very simple situation. In this case, also a simple contract. But the contract shows the basics of what a contract should look like, an executable contract. These contracts are smart because they're executable. You can't execute a transaction without having signed the contract. And of course, that could be a digital signing, and there could be all kinds of encryption protocols involved in the signing. So, how does this work? How can we construct a business blockchain? So that's a high-level conceptual blockchain. An actual business blockchain with processes and contracts and data from a business blockchain model. Well, we do it like this. We make a conceptual model of the business blockchain. The components of the business blockchain are transactions, contract forms, and contract structures. Contract forms are just text. It's something an end user can read and understand. It's just to make intelligible to the end user, what he has to expect from this contract and what not. This can then be transformed into something that can be implemented. For example, you could implement this as a database, yeah, and you could put constraints on this particular transaction event entity being check the precondition, check the post-condition, yeah? And you have a derivation rules that says that if I have a certain value, let's say yes, then I go to a certain follow-up, and if no, we go to another follow-up, and also check whether it's signed. Yeah? So these things can be automated. So what you have is, and this is the natural part of the blockchain, you see from a non-technical end-user business perspective, this person sees his business process. Then he sees his contracts. Yeah? And he knows it has to be transparent, it has to be safe. That's what the contract has to do because it elicits, yeah? It makes explicit what the terms and conditions are, yeah? And also makes explicit how the transaction is going to be followed up. And it also makes explicit within the context of the contract who is going to share, who's going to be in the sharing process of this data. Well, and extremely important, in the case of a conflict, yeah, there has to be a notion of traceability. So if there's a conflict, can I always look back in some kind of immutable ledger of transaction events and contract executions, whether the transaction has indeed been executed according to the specifications of the contract? So when there's a conflict or when there's an audit, yeah, you can always reconstruct history, yeah, and you can see whether there was an error made or not. This is what people like. That's what I've experienced. People who are non-technical domain experts in businesses, yeah, they now understand all of a sudden that the notion of a blockchain is a very natural notion, yeah, because there's a flow of transaction events governed by contracts, yeah, and there has to be a whole history, a trace of all of the transaction executions and contract executions. Yeah? So a blockchain is not something that is very esoteric. No, it's a very natural, everyday thing. Yeah? And once they get used to that, then they start thinking about, hey, a blockchain solution for my company might be a good solution. So you get something like this, yeah? If in terms, let's say, if you could implement it in terms of a database, that'd be something very simple, and sometimes that could be sufficient. What you do is the database just stores the transaction and the contracts, yeah? And if all of the conditions of the contract are indeed met, yes, then the transaction event with the contract form and the contract execution can be the next block in the blockchain. And then you proceed, according to the follow-up rules of the contract, to the next transaction event. So that's how that works. So, but another thing that's very important, I just have a few minutes left, is a benefit of a model is the possibility to validate the model. So you don't have to implement it first. Of course, having a prototype or a demo will always help, but you can also debug your models in a systematic cycle. It's like how an architect designs your house. You don't have to build the house before you can start criticizing it. Yeah? You can start criticizing models and mock-ups of the house before you start actually building it. So what you try to do is you try to get all of the requirements into the model, the process model, the contract model, yeah? And then you pose that, you let the person who wants this business process being put eventually into a blockchain, you let them see that, or the whole team. And what you see is you get criticism. We use a so-called regulative cycle. We're trying to actually extract negative feedback from everybody. And then with that negative feedback, we go into the next cycle, improve the process, improve the contract. And again, you cycle just as long as you have to for it to converge to a stable result. So that's how it works. That's what we call the regulative cycle, and this is the way you can use, you get in an agile manner towards the end result of an accepted model. And actually, this is not new either. This is something that Sir Karl Popper, an extremely important philosopher of science, already said. He says a theory, in our terms, a model, is just a hypothesis that is in constant need of falsification. So what we have is assumptions about domain experts, because that's what models are, they're just assumptions, and they're systematically challenged, and you're trying to debug your process model. So what you're trying to do is also debug your contract forms, and you're trying to get rid of your business bugs. Yeah? So do we have a perfect understanding of our process, of our contract, yeah, before we start moving towards implementation? But you know for sure, if your business models are wrong, then your software is certainly going to be wrong. So to round up, we're looking for transparent, safe, and traceable solutions Smart contracts, they could actually replace many centralized businesses. Business to business in this setting is extremely easy because we just have a notion of non-centralization of private blockchains communicating with each other. It's one possible architecture. But all these models, they could form the basis for any kind of architecture, be it decentralized or distributed also, that could fit a certain application. Okay, well, I hope that the benefits are apparent. Yeah, we're talking about solution spaces with these models. They could lead to many software architectures and implementations, but you can also validate these models from a business user perspective. I also want to just for acknowledgements, without the help of my colleagues at Contracts 11, especially Henk Doornbos and Berko Beurten, I could not have had expressed all of these thoughts. So, if you want to know more, here's my email address, and I gladly answer all of your questions.
Thank you, Herman. Is there room for one question before I introduce Johan? Is anyone with a burning question to Herman? Over there, where's the cube?
Am I working? Yeah. You describe smart contracts in the way that I would describe simply business logic and business rules. What I find maybe for the whole community quite interesting is that we don't see any reference to things that are being applied in let's say, the more mainstream IT terminology, etc. And we're all talking about things that have been developed in other domains already. And now, because it's blockchain, we call it differently. Do you recognize that, or am I talking gibberish?
Of course, I understand. I expected that question, of course. The thing is, what I wanted to concentrate on is the part of conceptual modeling. So how do you model a business process, which is not all that. That's something that has only gained a certain degree of perfection, let's say, over the last 5 years. And how do you model the notion of a contract? Yeah. So you have these things like situations, preconditions, postconditions, context, and that's extremely important because there's a notion that is transitive, because you have to see if you're saying this contract applies to this particular transaction, and it also involves other transactions. There's this transitive notion of contracts referring to other contracts and other contracts. So you have to know that when you sign one contract, you're implicitly also signing a whole load of other contracts. My idea is to show, in terms of a conceptual model, what the consequences are when you're thinking in terms of processes and contracts, and traceable solutions. Sorry?
Yeah, we're in full agreement. I'm just wondering is why we talk about this as being something entirely different, because this has been done with, let's say, the business rules, logic, decorative modeling, etc. Already.
I've been in this field for all of my life. This is you don't see people talking about blockchains and contract models in these terms. You don't see it. What you see is people talking about businesses. You see people talking about processes. What you don't see is that there is an explicit link going from the process models to the data models, and that the glue is the contract model.
We'll talk about that.
Okay.
Promise.
Yes.
Thank you, Herman.
Okay, thank you.